Okay, given two vectors, v and w, the dot product breaks them into two pieces, a component tangential to w and a component normal to w. So give formulas for both. Okay, so actually before the formulas, we'll need a picture. And I just draw the same picture every time because then it helps me get the formulas which will work with every picture. So here's v and here's w. And let's say, let's choose green for, what I'm doing here is I'm dropping a 90-degree angle and sort of projecting v tangential to w. So it's in the same direction to w, means tangential to w. And sort of the rest, you could view it as this vector right here, or you could view it as this vector right here. Well, it's hard to draw. Okay. And they're the same vector, this orange one. Okay. And then, first I'm just going to label this. This is normal to w. So it's weird because normalized means something different, but normal means 90 degrees. So that angle is a 90-degree angle to w. And remember, it's normal to w, okay? And then this part here is tangential. Tangential to what? To w. To w. Okay, and now I need formulas for them. So formula should be in black. And so here's the formula for projecting v onto the direction of w. So you see here that this is a number, this is a number, this is a vector. And so it's some amount of w, which means it's somewhere along w. In fact, it's this green vector. Okay. And the other one, well, is, if we draw the orange one up here, then it's final minus initial. So final minus initial means that it is, that its formula is v minus the green. It starts there and it's ending at v, so it's v minus that. Okay. So the subtraction of two vectors. In fact, it's a linear combination of two vectors. Okay, that's it. Now, what's part B? Explain the projection formula. So first, what is the projection formula? So I just put in words that the projection formula is, and I'll even just point to it, that. So that's the projection formula. Why is it projection? Because we're taking v and we're projecting it down onto the direction of w. And so that's why it's called projection. Okay. Okay, now I have to explain the projection formula using triangles, the normalized vector, which is a unit vector. This actually doesn't have anything to do with 90 degrees. And properties of the dot product. Okay, so I need to use all those things. Okay, so what are we going to do? First, we'll draw a picture. Really, it's going to be this picture, but with less clutter. And we're going to highlight different parts of the picture. So let's look at this picture again. There's v, there's w. And now we're going to look at this triangle. So this is a 90-degree angle. And this, we're going to call it theta. And then we're going to say this length here, length is, well, the hypotenuse times the cosine of theta, right? This is that, and then this one would be the hypotenuse times the sine of theta. But what is the hypotenuse? Usually we'd call it r, or a row, but in this case, it is the length of v. So then I'll put in my green vector. And then in words, again, I'll say in words, the projection vector, this one, has length v cos theta and direction w hat, where w hat is this normalized vector of w. So what does that mean? It means that we literally have, like, down here somewhere is w hat. It has length 1. W hat has length 1. And then, so if we multiply w hat by this number, then we'll get the green vector. So I will just say that in words. Multiply, or another way to say it is you scale w hat by v cos theta gives, let's give this a name. Let's call it p for projection, gives p, the green vector. This is p, okay? And so that's the first step. And so what that means is that p is equal to v. Oh, now I'm actually switching to formulas. So now I'm going to do some calculation. V cos theta times w hat. Well, that's p. That's what I'm saying here. Well, that's v cos theta times w over the length of w. That's just the definition of w hat. And now, at this point, I sort of recall that v dot w is equal to the length of v times the length of w times the cosine of theta. And I have a length of w, but it's downstairs. It's sort of down in the denominator. I would like it to be right there. I'd like it to be there. So what I do is I will multiply by 1. Multiplying by 1 doesn't change things. And the specific one I will multiply by is that one. So what do I get? I get cos theta w over w hat. Or no, over the length of w, and then the length of w over the length of w. So this is 1. So I didn't change anything. From here to here, I just multiplied by 1. And now I can rearrange. So you see that, the only vector here has been the whole time this thing. W hat was a vector. But then we split it into another vector and a number. And so now we recognize, and I'll continue with my formulas, that v dot w is here. And we recognize that this is the length of w squared. Right, so right here, maybe we'll say, what I'm remembering is that the length of w is the square root of w dot w. And so length of w squared is just w dot w. And now I'm done. I am done. So maybe this part should be in red, because it's sort of words. I'm explaining between the formulas. But you see that we have it. We've explained it using triangles. There's the triangle. The normalized vector. There's the normalized vector. And properties of the dot product, like these properties of the dot product. I think that's it.